Hello, welcome to Chapter 5, Homework Questions 133 to 138. Question 133. Examine trapezoid ABCD below. Find the measures of all the angles in the diagram. Alright, let's see what we can do here. We have actually three sets of parallel sides, so let's work with those and see what we can do. So here's one set. Alright, and so if that is parallel, then we know that, I'll try to mark these, but these would be corresponding angles. So we know this angle is 60 degrees. Now we can use triangle angle sum theorem to state that that is 80 degrees. We also can use, let's see, this set of parallel sides to say that this angle right here, this 80-degree angle, and this one down here, those would be alternate interior angles, so that means this is 80 degrees. And then this whole angle represents a straight angle, so that has to add up to 180 degrees. So that's 140, so that means this would be 40. And then once again, triangle angle sum theorem means that would be 80. And if I can add some more stuff, so this set of parallel sides, this one and this one, if we look at this transversal that cuts it, then this 40 degrees should match up over here with 40 degrees. And then the triangle angle sum theorem, that's 120, so this would be 60. So a little sloppy there, but I think we have found all the measures of the angles in the diagram. Part B, what is the sum of the angles that make up the trapezoid ABCD? That is, what is the measure of angle A? So let's just kind of go along here. Measure of angle A is 40. The measure of ABC, so see if I can get a different color here to try to mark these so we can see them. ABC, so A, that's not a great one, let's try this. A, B, C, so that angle is 80 and 60, so that's plus 140. BCD, BCD, so that's this angle, it's 120, plus angle D down here, and that would be 60. So if we add all of those up, you're going to get 180, that's going to be 300 plus 60 is 360 degrees for the sum of the angles of a trapezoid. Question 134. Use your triangle tools to solve the problems below. Find PR in the diagram below. Alright, so we have the angles of the triangle. We also have angle Q of that triangle, so we can find this side length of the triangle because we have a side, an angle, and a side, so we can use law of cosines to find the angle. So that would be, call this little, well, probably should call it little q across from angle Q. So this will be Q squared equals 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of 70 degrees. Plug all of that into your calculator at once. So I got 74.69 approximately, took the square root of that, and Q is approximately 8.64. So PR is approximately 8.64 centimeters. Part B, find the perimeter of the quadrilateral PQRS. So we're missing this length and this length, but they will be the same. They are congruent because we have 35 degrees and 35 degrees. So we'll just call them X. We can use law of sines. So we'll do sine of 35 degrees over X is equal to sine of 110 degrees over the length that we just found, 8.64. So we'll get X times sine of 110 is equal to 8.64 times sine of 35 degrees. Divide both sides by sine of 110, and X will approximately be 5.27. So to find the perimeter, we have two lengths that are 5.27 plus 7 plus 8. So the perimeter will approximately be 25.54 centimeters. Question 135. Find the area in the perimeter of the triangle ABC below. Give approximate decimal answers, not exact answers. So, kind of when they start to say that might get you thinking how we can find exact answers. Well, this is a 30, 60, 90 triangle and a 45, 45, 90. It doesn't mean we can't use our special right triangles. We'll just have to make sure that we plug the answer in at the end to get the approximate answer. So you can also use your trig ratios. So for this 30, 60, 90 triangle, this is the short leg. So I know that the hypotenuse is going to be twice that if I'm using my special right triangles. And then the long leg, which is across from the 60, is 4 square roots of 3. Once again, if you don't remember your special right triangles, then go ahead and use your trig ratio. So you could use, for example, sine. You could do sine of 30 degrees is equal to the ratio opposite 4 over the hypotenuse. We can just call f or whatever. And then you would see that it is 8. On the other side of the triangle, you have 45, 45, 90. And we know this length is 4, so this length down here has to be 4. And then the hypotenuse is the square root of 2 times the leg, so it'd be 4 square roots of 2. So if I want to find the perimeter, I'm just going to add all those up. It would be 4 square roots of 2 plus 4 plus 4 square roots of 3 plus 8. And then you can just plug that in to the calculator to get the approximation. And that will be 24.59 units. So there's the perimeter. To find the area of the triangle, it's 1/2 base. Now the base would be 4 plus 4 square roots of 3. It's that whole length right here. And then this would be the height, which is 4. And then once again, to get the approximate answer, go ahead and plug that in the calculator. And so the area is approximately 21.86 units squared. Question 136. This problem is a checkpoint for writing equations for arithmetic and geometric sequences. It will be referred to as checkpoint 5b. Write an explicit and recursive rule for t of n equals 1, 4, 7, 10. So we can see that the pattern is being added each time repeatedly by 3. So there's two things we need. We need the growth, so we know it's being added by 3. But we also need to go back and figure out what the initial term or term 0 is by working backwards, which in this case would be -2. So the explicit equation would be t of n, and this is the equation that would allow you to find any term number by plugging in. So t of n is equal to, the growth is 3, so that's 3n, and the initial, the starting value is -2, so it'd be 3n minus 2. Remember, this is arithmetic sequence because it's repeated addition. To write the recursive, that would be your explicit. To write the recursive, it would be t of, and the recursive means you're trying to find the next term by using the previous term. So it's t of n plus 1, that's the next term, is equal to the previous term. What are you going to do to the previous term? Well, you're going to add 3. So that's the recursive. The only thing that you have to add to this is where does it start? You know, what is one of the values? So t of 1 is equal to 1. That way you're starting at 1, and then you're adding 3 to that to get 4. If you don't have that piece, then you don't know where you're starting with the recursive. So both of these are necessary to write the recursive. So these are your two answers for Part A. Part B, write an explicit and recursive rule for that pattern. So on this one, we're going from 3 to 3.5 to 3/4 to 3/8. It looks like we are multiplying by 1/2 each time. And then we would have to work backwards and divide by 1/2 or multiply by 2, so that would be 6. So for this one, the explicit. Now this is repeated multiplication, so we still have our initial, which would be 6, and that is getting multiplied by 1/2 over and over and over again. So it's 6 times 1/2 raised to the n. The recursive would be t of n plus 1. That's the next term. So you take your previous term, t of n, and you multiply by 1/2. So 1/2 times t of n. Once again, we need to include that t of 1 is equal to 3, so you have that starting value. Part C, an arithmetic sequence. So you're given a table on this one, and it's telling you it's arithmetic, so we need to add something to this to get to the next one. Same thing here, it has to be constant. So what's 17 plus b has to equal 3. So that means 2b, subtract the 17, that would be negative 14. So it looks like we would be adding negative 7 each time. So let's take a look. So if we add negative 7, that would be 10. And if you add negative 7 again, that would be 3. And if you add negative 7 again, that's going to be negative 4. So you have those spaces in between there, but you can figure out, what you need to add to get to the next term. So we know the growth is, well, in this case, decay is going down by 7, and t of 0, if we work backwards, that would give us 24. So therefore, our arithmetic sequence for this one would be t of n is equal to negative 7n plus the initial of 24. Now this one doesn't say write both, so I'm just going to leave it in explicit form. D is a geometric sequence, so we're looking for multiplication. So, what do you multiply 7.2 by to get 8.64? So you can kind of set up an equation and work backwards. So if you take 8.64 divided by 7.2, that will give you your multiplier, which would be 1.2. And then once again, you can work backwards to complete the table. It doesn't actually say to complete it, but I'll complete it, and then to write your equation. Now, we do need to kind of go back because we do need to know what term 0 is. So I went back and completed the table. Since the multiplier is 1.2, anytime you're going backwards, you're going to work backwards from that. So if you multiply by 1.2, you're going to divide by 1.2. And so now we have all the information we need. We just need to write the equation. So t of n is equal to your initial, which is 5. That is being multiplied by 1.2 over and over again, so we'll raise it to the nth power. Alright, and part E. If an arithmetic sequence has t of 7 is 1056 and t of 12 is 116, what is t of 4? So because it's arithmetic sequence, we have 7, 1056, and then 12, 116. And once again, since it's arithmetic, it grows at a constant rate, so we can actually find that growth by finding the slope. So m is equal to 1056 minus 116 over 7 minus 12. So I have, 940 divided by negative 5, which will be equal to negative 188. So that's that growth. And then we need to know what t of 4 is. But we still need to figure out what the initial is, or t of 0, which is the y-intercept. So can we find the y-intercept given 2 points? Absolutely. We can just take one of those 2 points. I'll take the point 12, 116 with our slope of negative 188 and plug it in to y equals mx plus b and be able to solve for b. So I found the b value, which means we can write the sequence. T of n is equal to negative 188 times the term number, and then plus your initial, which is 2,372. So if I want to find what t of 4 is, I can just now plug in 4 into the sequence. Now, I went through and did it algebraically. There's obviously potentials for other things that you could do to solve for this. Maybe set up a table, find the missing values that way. And that's fine too. So T of 4 is equal to 1,620. Question 137. Bob is hanging a swing from a pole high off the ground so that it can swing a total angle of 120 degrees. Since there is a bush 5 feet in front of the swing and a shed 5 feet behind the swing, Bob wants to ensure that no one will get hurt when they are swinging. What is the maximum length of chain that Bob can use for the swing? So part A, we want to try to draw a diagram of this situation. So we have a swing. Let's call this the top of it. And it's going to swing in this direction and then in this direction. We have the bush that's in front of it, and we have the shed that's behind it. It can swing 120 degrees, so that would be this angle up here. And since the chain is the same length on both sides because it's swinging, these two are going to be equal to each other, which means these angles need to be equal to each other. And so if I have 120 degrees, there's 60 left, so that means each of these will be 30 degrees. And this total distance down here is 10 because the bush is 5 feet away from the swing, is another 5 feet away from the shed. And we do know these two lengths here are unknowns, so, and they are both the same, so it is, we can just call them x. And I think that kind of gets us going here. So these would be the chains, and then the distance between the bush and the shed. Alright, on B, what is the maximum length of chain that Bob can use? State what tools you use to solve this problem. So to find x, we potentially could actually break this up into a 30, 60, 90 triangle, and we could use our special right triangles to help us solve this. We do know that the bottom base is 10, but for the 30, 60, 90, they would both be 5. And that would be the long leg. Now, we haven't done a lot with where we're given the long leg, but we can work backwards from that, just like if we have the short leg, which would be, we can call this, let's just call it h for the height. We know that the hypotenuse is twice that. We also know that the long leg is the square root of 3 times the short leg. So for example, the short leg h, if I take that times the square root of 3, that's supposed to be equal to 5. So we could divide by the square root of 3 to get that. So 5 divided by the square root of 3 would be the height here to here, and then twice that would be the hypotenuse. So x is equal to 10 over the square root of 3. And that would be approximately 5.77 feet. And so that does answer the question in terms of the maximum length of the chain. Would be about 5.77 feet. Now, if you didn't want to use your special right triangles, that's perfectly fine as well. You could have used the original triangle, not as a right triangle, and potentially used law of sines or law of cosines. You also could have still broken it up into your special right triangle and just used your trig ratios. So, for example, on this, if I have 30 degrees and I know this is 5, I could have used cosine of 30 degrees is equal to adjacent over hypotenuse, and then just solve for x this way, which might have been a little bit easier on this one. And you still get the same answer. So once again, lots of different ways you can look at this. Alright, question 138. On graph paper, triangle ABC is 3.2, negative 1, 4, 0, negative 2. I'll plot that in just a second. We want to find the perimeter of that triangle. So let's go ahead and plot A, which would be 3, 2. B is negative 1, 4. And C is 0, negative 2. So here's what we're looking at for our triangle. And we want to be able to find the perimeter. So to find the distance of each of these, we can actually set up right triangles for all of these. For example, A to B, we know this is 2, and then this would be 4. So that would represent, AB would represent the hypotenuse of that triangle. And so AB squared is equal to 2 squared plus 4 squared. So AB squared is equal to 4 plus 16, or 20. So AB's distance would be the square root of 20. And you can do that for the rest of them. So for example, on B to C, we can go here to here and make a right triangle. That would be 1 and 6. So therefore, BC squared is equal to 1 squared plus 6 squared. 36 plus 1 is 37. So therefore, BC is equal to the square root of 37. And then the last one, we'll go here, and this would be 3 and 4. That's a special, it's Pythagorean triple 3, 4, 5. So you can use that, or you can use Pythagorean theorem again. So AC's distance is 5. So if we are looking for the perimeter, we can take the square root of 20 plus the square root of 37 plus 5. And that would give you a perimeter approximately of 15.55 units. On part B, it wants you to dilate triangle ABC from the origin by a factor of 2 to create a new triangle, A prime, B prime, and C prime. And then what is that perimeter going to be? So I'm going to erase kind of all my stuff here and then just start over with ABC and then dilate it by a factor of 2. So for A, I go from the origin, go over 3 up 2. So to do that again, that would dilate it by 2. So there's A prime. B prime up 4 over 1. So do that a second time to increase it by a factor of 2. And then C is at 0, negative 2. So you can just go down another 2 to get C prime. So this would create your new triangle. So for part B, you can go through and redo what we just did in part A, or if you remember what we talked about with perimeter and how it changes with the dilation is it gets multiplied by 2. So you can take your original perimeter and multiply it by 2, and that'll give you approximately 31.11 units for the new perimeter when you dilate it by a factor of 2. Part C, if triangle ABC is rotated 90 degrees clockwise about the origin to form triangle A prime, B, or double prime, B double prime, C double prime, name the coordinates of C double prime. So I went ahead and rotated the whole figure, but it only wanted coordinates C double prime, so I could make that easier myself. But either way, rotated it. Make sure you rotate it clockwise. And so I'm taking the points and going 90 degrees. Remember, you can also use tracing paper to show that rotation. But we come up with C double prime to be negative 2, 0. Because you're taking this point and rotating it 90 degrees.